Hi everyone! This problem is for my English speaking students and also for me to practice my English, so let's go solve it. We have here a motor which is oscillating at a frequency of 120 Hz and it's fixed at these points P and Q, and then hanging from the string we have a weight W which is equal to the mass of the subject times G. So the distance between these 2 points P and Q, which is the length of the string, is equal to 1.2 meters. The linear density of the string is 1.6 grams per meter, and we want to know which tension is needed here. If I want to observe here this pattern with 4 loops, which corresponds to the fourth harmonic. So we should remember that inside each loop there is contained a half of a wavelength. So we have 4 loops here, we have 4 halves of a wavelength and 2 complete wavelengths, because a complete wavelength is when the wave repeats itself, that is up until this point. So inside the length of the string between these 2 points, we have 4 loops, which is equal to 4 times lambda divided by 2. So this is the same as saying that L is equal to 2 times the wavelength, or that the wavelength in this harmonic is equal to L divided by 2. On the other side, we have this relation between the speed of the wave, of any wave, and its frequency and wavelength. And particularly in a string on a wave, we have that the speed is equal to the tension of the string divided by the linear density of the string. This is the speed of the wave, and that should be equal to the frequency times the wavelength, which we already know that is equal to L divided by 2. So we solve this for the tension, and by squaring, taking the square of all this, we have that the tension divided by the linear density is equal to all this term squared. So the tension is equal to mu, the linear density, times the frequency, the length, divided by 2 squared. And by substituting the values for all this, we have that the tension is 8.3 newtons. And the tension should be equal to the weight of this object, which is mg. So the mass that we need to hang in this point should be equal to 8.3 divided by g, which is 9.81. And finally, the mass needed is 846 grams. This is the mass that we need to hang here if we want to observe a pattern with 4 loops. So that's it. This is Kuko, and he wishes you to have a very good day. Bye.